Your homework help for 12.1 is going to consist of 4 problems today. You're going to take a look at finding the limit as x approaches -2 of this function by creating a table of values. So kind of like we did in the notes, where we're gonna make a table and we're gonna use our calculators to help us out with that. Second one, same type of problem, finding the limit as x approaches -3 of this function. Again, you want to plug -3 in for x if you can, but it's going to make the denominator equal 0, like -2 will make the denominator equal 0. So it doesn't allow me to just plug the number in by direct substitution, they would call it. So going through the strategy of making the table again to find the limit. The third problem is going to ask us to find the limit of a function like this, and happens to ask us to find the limit as x approaches 2, and we'll take a look at that one. And then the last one is just evaluating a limit with a trig function in there. Alright, so looking at the first one, it specifically tells us to create a table of values, so that's kind of a clue to tell you that by plugging -2 into the denominator, it's going to make it equal 0, but that's what you usually want to check for. If you can just plug this number in and the denominator is not 0, plug it in. Of course, it's going to be 0, so what they want us to do is make our little table of values here. So, I'm going to make this table like we did in the notes, where we're going to make our x and our y's, and then you should give yourself 7 different spots here. 1, 2, 3, 4, 5, 6, and 7. So give yourself 7 columns. And the one in the middle, that is where we're going to put an x value of -2. And we're going to figure out what's actually happening here. Alright, so what you want to do is you want to get closer and closer to -2 as you come from the left and as you come from the right. Remember when we did this in class, you want to become extremely close. It's not going to be something like 1, 0, -1, -2. We want to get very, very close, so decimal points. So usually what we do is we'll have 3 decimals here, 2 decimals, and 1 decimal, and that'll progressively get very, very close. So as I'm on the right, this would be -1.999, which is extremely close to -2, but it's to the right of it. -1.99 would be a little bit further away, and -1.9 would be a little bit further away. So as you come from the right, these numbers are getting closer and closer to -2. And then think about doing the same thing as you go to the left. A number a little bit smaller but really, really close to -2 with 3 decimal places would be -2.001, -2.01, and -2.1. So those are the numbers that you would want to use. Alright, and we're going to use our calculators. They want us to take all these numbers and plug them in for x, and of course that would take a little bit of time to sit there and do that. So I'll run through a couple ways to do it. I'll show you the first way to do it, and then I'll show you the way that I kind of like to do it better. But it's completely up to you which one you like. Alright, so I've got my calculator on. First thing you're going to have to do is you're going to have to enter that function in. So go to y is equal to, go ahead and type in x plus 2. Now this is a quantity in the numerator, so make sure you have parentheses around x plus 2, or unfortunately you're not going to get the right graph. Divided by, it's a quantity in the denominator, so make sure again you have parentheses. X squared plus 5x plus 6. Go ahead and hit enter. And if you want to take a look at the graph, you sure can. Now it's asking us what the limit is as x approaches -2. Just by looking at this graph, we should be able to figure it out. By looking at that graph, x is equal to -2 right here. You can see as I approach on the left, it's going to drop off to -infinity. As I approach from the right, it's going to positive infinity. They are not approaching the same number, or a specific number for that matter, so that we would say this one's unbounded. So I know the limit does not exist, but that's not what they're looking for necessarily. Yes, they want to know the limit, but they want us to fill this table out. So if all I asked you was what's the limit, you could look at your calculator and say, well, the limit does not exist. Now to fill out this table, if you look, oops, sorry about that. If you look right above the word graph, you see the word table. So if you hit second and then graph button or table, it's going to give you a list of values, and notice it started at 1.992. You can have this start wherever you want. But that's kind of nice. What this is saying is if you plug 2.01 into this function, that's the y value that you would get, which would help us fill this thing out. Now, what I don't want to do is I don't want to sit here and scroll until I get to -2, because that's going to take a while. So what you can do is this. See the button that says window on it? Right above it, it says table set. You're going to hit second and then window, or table set. The table start button, that is going to be whatever you're trying to find the limit of. We're trying to find the limit as x approaches -2. So I'm going to say -2, hit enter. The change in the table, this decimal point, you always want to have either 0.1, 0.01, or 0.001, or so on and so on. To get these two numbers, since they're 3 decimals away, I'm going to say it's 0.001, hit enter, and then I'm going to go back to that table. So if I hit second, graph, notice it tells me that at -2 there's an error. I knew that. There's either a hole or an asymptote. We actually know there's an asymptote. At -1.99, which is this one right here, I actually get 0.999. Now unfortunately it doesn't tell me what I would get with 2 decimal places. I have to go back and do the table start thing over again. If I scroll up, I can see at -2.01 that I would get 1.001. Alright. So, if we continue to do this, if I go back to table set, so second table set, tell it that I want to start at -2, hit enter. This time do 2 decimals, so 0.01, hit enter. Go back to the table, and now you'll see it gives you what you have for the 2 decimal places. This would be 0.9901, and 2.01 would be, or -2.01 would be 1.0101. And then of course if you want 1 decimal place, go back to the table set, tell it again that you want to start at -2, and then 0.1 for 1 decimal place, go back to the table, and now at -1.9 it would be 0.90909. Scroll up, and at -2.1 it would be 1.1111. Alright, and looks like I made a mistake when I said that the thing was going to be undefined. I was talking at -2. If you look a little closer at this graph is actually undefined. It's at -3. -2 is right there, so it actually does approach a specific number there. And obviously you can see it on the table, which is a good thing I didn't just look at my calculator and I looked at the table. As you come from the left, it looks like you're getting closer and closer to 1. As you come from the right, it looks like you're getting closer and closer to 1. So your answer is the limit as x approaches -2 of that function is 1, whatever it looks like it's approaching. Alright, so again, it looked like when I first glanced at it, I thought that was -2, but that's actually -3. It's hard to see the tick mark, but that's actually -2, so be careful with that. Alright, so going to go ahead and do the next problem. Same way. Going to go ahead and graph this, so go to y is equal to if you haven't done so already. Type this function in. Now this whole thing is a quantity in the numerator, so make sure again there's a parenthesis. It's the square root of 1 minus x. And then I have to close my parenthesis to show that that's the radical. If you don't have that parenthesis, you just arrow to the right to get out of the radical. Still have -2 in the numerator. Close the parenthesis for the numerator, divided by quantity again, x plus 3. Really the only thing that you have to be careful with when you're doing this is getting the thing typed in correctly. That's where you most likely make your mistake, and of course it's going to give you the wrong graph, and then obviously you're going to get the wrong answer. Looking at this doesn't look all that helpful. Looks like here at -3 it approaches something, but it's kind of hard to see it. I could easily zoom in on it, but I'm not going to do that. I'm going to go ahead and make the table since they want me to do that anyway. So let's go ahead and draw out our table. And we've got x and y. Again, give yourself 7 columns here. Alright, and then -3 should be in the middle, so -3, and I want to figure out what's happening there at -3. Again, numbers to the left and right progressively with the decimal points. This would be -2.999, -2.99, and -2.9. This would be -3.001, -3.01, and -3.1. Alright, now I'm going to go back. I said there was 2 ways, and I showed you one for the first problem. I'm going to show you the second one here in just a second for this problem. Let's pretend I used the table set thing. Let's say I go to table set, and I know it's asking me for -3, but I'm going to say -6 just to do a different number. And I'm going to go by 3 decimal points. Alright, now why this table is kind of nice is, let's say I arrow up, So that negative 6 is right in the middle. Remember, that's what I was trying to look for, the way I set this up. Imagine if you took your calculator and did this with it. Here are the numbers coming from the left. Here are the numbers coming from the right. All you got to do is look at these decimals and say, what's it look like it's approaching from the left, and what's it look like it's approaching from the right? According to this, it looks like it's approaching negative 0.2152 or 3, depending on, I guess I would say 3 since it's right on the 6. So you can actually see the table basically sitting here. Now we changed our numbers around, so you can either do the table set thing, or here's another thing you can do. So I'm going to go to graph. What you can do is go to second and then trace, or the calc button, where you see a lot of other things. You see the very first one says value. Pick number 1 or hit enter, and then it says x is equal to. All you have to do is type in this x value, hit enter, and it'll tell you what the y value is. So say negative 3.1, enter. There's what your y value would be. It's negative 0.24846. And then without doing anything, you don't have to go back and redo that again. Just type in your next x value. So type in negative 3.01, enter. There's your next y value. It's negative 0.24984. Negative 3.001, enter. It would be negative 0.24998. So I kind of like this way better. All you got to do is just sit there and keep entering the next number in, which is helpful anytime you have to make a table of values for any function. Go ahead and type in negative 2.999, hit enter, and it's negative 0.25002, let's say. Negative 2.99, hit enter, it's negative 0.25016, and negative 2.9 is going to give me negative 0.25158. So either way you like to do it, whether you like to go to table set and then change the table around, or whether you like just entering the numbers in, they take probably about the same amount of time. Now go ahead and look at your table. When you look at your table, what does it look like it's approaching? Well, from the left, it looks like I'm getting closer to negative 0.25. From the right, I'm also getting closer to negative 0.25. So my answer would be negative 0.25, or I know that that's actually 1/4. So there's what the limit is. Doesn't mean that the y value actually equals negative 1/4. It's just that the y value is approaching it from both sides. More than likely, because I can't plug negative 3 in here because it's going to make the denominator 0, more than likely that means there's a hole there. Alright, on to the next one. Here they are asking us to graph this piecewise or compound function and then tell us whether the limit exists as x approaches 2. So let's go ahead and graph this thing out. 2, 3, 4, 5, 6. So go ahead and give yourself a graph. I'm going to go 6 tick marks each direction. I hope that will cover everything. If not, we can always add on to it. Alright, so I've got my graph set up now. So if I go ahead and start graphing this, I'm going to graph the first function. It's negative 2x, so it's a line, has a y-intercept of 0, has a slope of negative 2, so go down 2, 1 to the right. And remember, there's a couple ways to do this. You can either draw this thing in very, very lightly. So there's what the line would look like. I want my x value to be less than or equal to 2. So if I plugged 2 into this function, I would get negative 4. So that's my starting point, and it's going to be a closed circle because it's equal to. So 1, 2, 1, 2, 3, 4, it's right here. I should have a closed circle here, and then notice it says x is less than. It wants me to make the stuff to the left of that point darker. So this is the thing to the left. So this is actually the graph. And it will continue to go on forever. And so I don't need this part of it. So hopefully you made that really light. Now it might be a good idea to label this point as 2, negative 4, so you can refer to it. Alright, now let's go ahead and take a look at the parabola. Going to probably want to, you can, like I said, you can do this 2 different ways. You can either plug 2 in immediately and then just kind of give it a rough sketch, or I'm going to draw the sketch of the parabola in. I need the vertex point, so I've got to do the negative b over 2a thing. Negative b is going to give me positive 4 over 2a, or 2. My x value for the vertex is 2, so that means it must be the vertex point that I'm about to draw here. And if I plug 2 into this function, I'm going to get 2 squared minus 4 times 2 plus 1. That's going to give me 4 minus 8 plus 1, or that gives me negative 4 plus 1, or negative 3. So my vertex point is 2, negative 3. Just so happens if I plug 2 in here, I get negative 3. They're actually talking about the vertex point. I want that to be an open circle. There's no equal to. So 2, negative 3 is right here. And then my parabola opens up. So a very rough sketch of it would look something like this. They want everything to be to the right of this starting point, so the graph should look something like this. So there's my graph. And now all I have to do is ask myself what happens as I come from the left and what happens as I come from the right at 2. Let's go ahead and label this point as 2, negative 3. And I'm looking at 2 because that's what they're specifically asking me for as x approaches 2. So x is going to approach 2 here. As I come from the left, I'm approaching a y value of negative 4. As I come from the right, I'm approaching a y value of negative 3. Those are not the same, therefore we say the limit does not exist. And when you're doing a problem like this, I believe we did one in the notes, you don't even actually have to graph it. If they give you the same number here, and that's what they ask for the limit of, and most likely that's what they'll ask for, all you have to do is take that number and plug it in. If you don't get the exact same number for a y value, then your limit doesn't exist. If you do get the same number, whatever that number is, that would be your limit. If I gave you this compound function or piecewise function, I said find the limit as x approaches 7, then you just got to ask yourself which one does 7 fit in, plug it in here, and that would automatically be the limit, because 7 would be like somewhere right here if I had enough tick marks in there. And of course, as I approach it from the left and the right, I'm approaching the same point. Just like over here, if it's anything that's not on 2 but it's in this region, it's going to approach whatever that number is that I plug in. Hopefully that makes sense. If that's a little confusing, have me try to explain that again, or maybe try to rewatch that. Last one's a little bit of an easier one. This is kind of a more of a day 2 thing. It's asking you to find the limit as x approaches pi of the tangent of x. Now for all these functions that we've been doing, here and here, I would say just take this number and plug it in for x. But of course the problem is when you did that in the denominator, you got 0. Well, I can take pi and plug it in here. I don't have a denominator. All they're asking you to do is find the limit as x approaches pi of the tangent of x, which by direct substitution means I'm just trying to figure out what is the tangent of pi. So you think on your unit circle, well, pi is over here. I know the value is negative 1, 0, the x and the y values. Tangent wants me to take the y value divided by the x value, and that's just 0. So the answer to this is 0. The limit is going to be 0. If you were to actually graph it, which you're not required to, you just need to be able to do it algebraically. But if you were going to graph it, remember we have asymptotes at pi over 2, at negative pi over 2, and the tangent looks something like this. And we have another asymptote here at 3 pi over 2. This right here is pi, and my graph just continues to do this over and over again. This is the one they were asking about, and you can see as you come from the left it approaches 0, as you come from the right it approaches 0, so that definitely is my answer. Don't have to graph it to do that, but that's what they're looking for. Alright, that is your homework help for 12.1. If you need any extra help, you're always welcome to come in and ask for it.